Our next speaker is Dr. Paul Anderson. Paul is a research scientist at the Mystic Aquarium, and he is the lead of the Coral Reef Aquarium Fisheries campaign. He's held positions at Mote Marine in Sarasota, Florida, the Pier Aquarium in St. Petersburg, and the Florida Aquarium in Tampa. He got a PhD from the University of Florida. He's a brilliant conservationist that values the importance of engagement, and he's here today to talk to us about the Coral Reef Aquarium Fisheries campaign. Please welcome Dr. Paul Anderson.
Appreciate it. Thanks so much, Tim, and thanks to all of you for being diehards and sticking it out to the very last moment of MACNA. I'm excited to share with you everything about our Coral Reef Aquarium Fisheries campaign today, and I have so many wonderful partners, and I can't wait to share with you their stories as well. The goal of our campaign is to empower sustainable coral reef aquarium fisheries that support biodiversity conservation, healthy marine ecosystems, including coral reefs, and the livelihoods and the food security of the people that depend on these fisheries throughout the global value chain. I want to talk to you a little bit about the economics of the coral reef aquarium fishery and kind of compare it to live reef food fisheries. So oftentimes in some of these source countries where our aquarium fish are sourced, the fishermen are the same people that also fish for reef fish for food for people. And so they kind of do both, but the ornamental fishery is far more lucrative. And so a kilogram of ornamentals is worth about $1,000 US, pound for pound. And if we compare that to a kilogram of live reef food fish, that's worth about $12.50. So the ornamental fishery is potentially far more lucrative for everybody that's involved in it throughout the value chain. There are many stakeholders. You know, there are the fishers themselves, and there are many different types of traders that we're going to go through in a minute or so. And this is an industry and an income source, and it provides for the livelihoods of folks and food security, so that they can purchase their food if they're participating in this potentially lucrative fishery. I'm kind of preaching to the choir. I'm sure most of you know about some of these issues with regard to unsustainable fishing practices that happens in some source countries, including very prolific source countries like the Philippines, with destructive collection methods like cyanide poisoning to stun fish, making them easier to catch and poisoning them and coral reefs in the process, dynamiting reefs for the same purpose to stun fish, killing fish and corals in the process, and large-scale netting across meters of reef, damaging everything in those nets' paths. On top of that, in some of these prolific source countries, there's little to no management or fisheries policy or enforcement of those policies if they're in place. And we know very little about those fisheries. We don't know if necessarily for the 2,000 species of ornamental fisheries that are traded, if each one of those species is being harvested at a sustainable level or not. That data is just not readily available. My colleague Andy Ryan showed this picture earlier, and I also am grateful to our colleagues at Cairns Marine, which is a really sustainable ornamental fish collector and trader and exporter based in Australia, and they're really active in industry education. They've presented at MACNA before, and I know they have a booth this year. They also put together this graphic of sort of the traditional value chain of the marine ornamental fishery. So you've got a lot of players here. You've got collectors that live in these very remote islands with coral reefs in their backyard, and they go collecting for fish. They then sell those fish to roaming traders. Those roaming traders then bring them to a consolidator. The consolidator will bring them to an exporter, then to a transshipper, then to an importer in the destination countryside, a wholesaler, then to a retailer, or a public aquarium, or maybe to a marine aquarium maintenance business, and then finally to a home or office aquarium. So there's a lot of people involved in this value chain, and everybody financially benefits from trading these fish in this value chain. So it's an important economic source to all these folks. But some of the issues associated with this complex value chain is that there can be poor husbandry. These fish are exposed to multiple trips and multiple changes of hand. They can be in bags for days. They can be overcrowded, whether in the bags or in holding tanks with no habitat, so they can't escape from other aggressive fish in their environment. And they're exposed to water quality extremes like high temperature and low pH and high ammonia that can stress them out. So there's multiple stressors that these fish are dealing with across the transport chain, and as a result, there tends to be high mortality in this kind of model. Let's talk about the numbers. About 22 million fishes are collected for the coral reef aquarium fishery globally every year. And they range from across about 2,000 species, and they're sourced from 45 countries. This data actually comes from my colleague Andy Ryan at the Roger Williams University, who did some really great research to understand the nature of the coral reef aquarium fish trade. And so let's look at us, the US, as a destination country. We are the largest global consumer. We take in about 50% of what is collected, and those fish go to 1.3 million home aquaria throughout the United States. And folks spend about $246 million annually on marine aquarium livestock. That includes fishes, also corals and non-coral invertebrates. And then if you add in the aquarium supplies like the stands and the lights and the tanks and the filters, folks collectively could be spending up to $2.6 billion in this industry. So, so there's a lot of cash trading around in this trade. So with all the environmental issues associated with collecting fishes for the aquarium industry, well, why don't we just shut it down? And of course, as we know, that has happened in some source locales. We at the Mystic Aquarium see a lot of benefits to marine aquarium keeping. In this day and age where kids are much more connected to technology, they tend to get more disconnected from nature, and that's especially true for kids that live in cities that don't have easy access to nature. So marine aquarium keeping is a great way to bring nature inside the living room where a kid can easily access it. They can connect with their family as they learn together how to take care of fishes under their care. They can learn hands-on lessons in biology, chemistry, and environmental science. And aquarium keeping fosters ethics of care and compassion. A child who learns how to take care of a fish grows up to be a responsible adult who is aware of his or her actions and the effects that they have on the world around him or her. So I really think that marine aquarium keeping is one promising avenue to inspiring environmental stewardship among the next generation. So how do we do this in a more sustainable way? Well, we got some of our friends and colleagues together to wrap our heads around these issues. You probably recognize some of the people in this photo, and they come from Something Fishy and Roger Williams University and a couple of other places. And we came up with a few themes where we can make a difference. And there are two of those themes that I want to present to you today because we made some really great headway in these themes. One is upgrading the value chain. So what does that mean? Well, right now, the value chain is really a volume-driven value chain. The collectors earn pennies for fish, so there's no incentive to take good care of those fish and ensure their survival beyond their hands. So if a fish dies, they just go get another one. That's a volume-driven model. We want to switch that to a value-driven model where collectors learn how to take proper care for their fish and as a result can charge a premium for a fish that they can verify has been cared for with best practices and that it helps to ensure survival all the way to the destination. So there's a couple ways we can do that. We can do that by developing a test to detect for cyanide-exposed fishes. We can do that by making decisions about which species to trade in the industry based on how resilient or vulnerable to overfishing they are. We can do that by looking at the industry and finding out where the strengths are and where the gaps are and where we can help. And really importantly, educating everybody in the value chain how to take great care of their fish so that they can reduce their losses, improve their profits, and improve environmental sustainability as a result. And another theme we've made a lot of headway on is through aquaculture research and development to try to get more of these species that are traded in the industry available as commercially aquaculture to help offset fishing pressure. So I'm going to first start by talking about some work that we're doing on cyanide detection with our colleagues at Roger Williams University and UMass Boston. So proud to have the opportunity to partner with Rationale and Tracy Romano from the Mystic Aquarium and Alex Bonanno, this year's MACNA scholarship winner. Cheers to Alex. And also Andy Ryan. Andy has been working on cyanide detection for many years, and he's really focused on trying to get a comprehensive physiological understanding of what happens in a fish's body when it's exposed to cyanide. And he's actually traveling down multiple pathways to be able to detect cyanide using different methods, and so is Alex. We've come on board with them more recently to develop a molecular type of a test. So I'm going to kind of just do this is sort of a map of our methods for the molecular test. And what we're doing for this is in a controlled laboratory situation, exposing model fish, the clownfish, to cyanide for 20 or 45 seconds, and then sampling them at certain time points after, so we can see, you know, how long after the fish is exposed to cyanide do we still see the cyanide signal in our molecular test that we're developing. And we use PCR techniques to be able to detect for whether certain genes